हेलो। Love Flower, ask everyone your part. Love, are you there?
Are you asking me, Suman?
No, ma'am. My student, one of my student just joined from
Okay,
MSc,
okay.
so I'm just telling him to tell everyone to join it. नीरा मैम, आपका ना फोन नहीं लग रहा है, एक बार फोन पिक करेंगे आप? नीरा मैम,
हाँ, सुमन बोलो।
आपका ना फोन नहीं लग रहा, एक बार आप फोन पिक कर लीजिए।
मेरा फोन नहीं लग रहा?
हाँ, नॉट रीचेबल आ रहा है काफी देर से।
अच्छा। नमस्कार सर।
हाँ नमस्कार जी। हाँ नमस्कार मैडम, नमस्कार।
नमस्कार सर। Thank you sir. Thank you for joining. Dr. Pooja, please
Yes,
start.
ma'am. Okay, ma'am. Okay. A very good morning to all of you. Respected Professor Somnath Sachevaji, worthy Vice Chancellor, Kurukshetra University, Kurukshetra, Professor Suman Berry, Punjab University, Chandigarh, and keynote speaker of today's event, Professor Neera Raghav, Chairperson, Department of Chemistry, all the colleagues and students present here. I welcome you all in today's program, which marks the celebration of International Day for Women and Girls in Science by Women in STEM Forum of Kurukshetra University, Kurukshetra. The Women in STEM Forum, Kurukshetra University, Kurukshetra, was established in 2019. This forum was constituted with the frame of background to empower the women faculty of science, engineering and technology, life science, mathematics to carry their research and career without any hurdle. This forum also guides them about available opportunities for their future endeavor. Further, it is a platform to identify the hurdles being faced by women in STEM and suggest possible solutions for these. We promote the girl students from schools, UG and PG courses to increase their scientific temperament to carry their careers in various streams of STEM through group discussion, interaction, workshops, lecture series, etc. After successful completion of 2 years, that is 2019, 20 and 2021, we are running the third year, 2021-22, under the leadership of Professor Somnath Sachdeva, Vice Chancellor, Kurukshetra University, Kurukshetra. The members of the organizing committee of this forum are Dr. Neera Raghav, Professor, Chairperson, Department of Chemistry, Dr. Sunita Dalal, Associate Professor, Department of Biotechnology, Dr. Suman Mahendia, Associate Professor, Department of Physics, Dr. Urmila, Assistant Professor, Institute of Engineering and Technology, Dr. Ruchi Gupta, Assistant Professor, Department of Electronic Science, Dr. Pooja, Assistant Professor, Institute of Environmental Studies, Ms. Anju Goyal, Assistant Professor, Institute of Pharmaceutical Sciences, Dr. Suresh Kumar, Assistant Professor, Department of Chemistry, and Dr. Hardeep Sharma, Assistant Professor, Institute of Environmental Studies. Today's program also marked the valedictory session of Science Carnival, which was organized by cooperative efforts of this forum. I take this opportunity to say a few words about Science Carnival. We are living in a developing country, and science has a very vital role to play in the development of any country and the world as a whole. Science has always proved to be a blessing for the mankind and transformed human life by inculcating various luxuries and comforts. It is the science which has helped man to reach the moon, measure the depth of the sea, and reveal many secrets of the living and non living. The importance of science in our day to day life can never be underestimated. In this context, we have organized the Science Carnival through online mode so that science can be performed or done with fun with the following broad objectives: to promote interest in science among younger generation, to encourage scientific and technological creativity and intensive research culture among students and inculcating a sense of pride in their talent, to give the opportunity to the students to develop social, moral, and communication skills. Four different events, namely science quiz, poster making, storytelling, and PowerPoint presentation competitions, were organized under the Science Carnival 2022. In total, 299 students from different schools of Kurukshetra, colleges under Kurukshetra University, and from different university teaching departments and institutes of Kurukshetra University, Kurukshetra, took part in these events under 8 different categories. Each activity was preceded by an expert lecture. Without taking much time and to formally start the event, I now invite Dr. Suman Mahendia to please play the Kulgi. Dr. Suman, please.
Yes, thank you, Dr. Pooja. Namaskar, sir. Namaskar, Suman Delman. So just give me a moment to share my screen and we'll start the Pulgit of Kurukshetra with lamplight, virtual lamplight name.
Thank you, Dr. Suman.
Over to you, ma'am. Thank
I
you.
now invite Professor Neera Raghav. I now invite
Am I
Professor
audible?
Neera Raghav
Am I audible?
for further proceedings.
Am I audible?
Yes, ma'am, you are audible, ma'am.
Thank you, Dr. Pooja. As the world continues to grapple with COVID-19 mutated strands, and therefore, in view of the greatest challenges currently faced by the academic community globally, where there has been a requirement to harness all talent online, really it is a very big task for academicians. In this context, WIS Kurukshetra University Kurukshetra organized an online science carnival 2022, a response from 299 registered participants validated the utility of the event. Our last event was organized under the aegis of RUSA and it was only for women participants. This time, with the aim to focus on one of the agenda of the International Day of Women and Science 2022, that is inclusion. This event was not limited to the girl students only. Participants from various different schools, colleges, university teaching departments, and institutes of Kurukshetra and affiliated with Kurukshetra University were there in the event. Today, on this occasion of 7th International Day of Women and Girls in Science, implemented by UNESCO and UN Women that aim to promote women and girls in science, I personally and on behalf of Women in STEM Forum am privileged to welcome Professor Somnath Sachdeva ji, Honorable Vice Chancellor, Kurukshetra University Kurukshetra, on final declaration of prize winners of various events in 8 different categories for Science Carnival 2022. Sir, without your motivation and support, the event would not have been in the present shape. Thank you very much. Professor Sachdeva has more than 33 years of rich experience of teaching, research, consultancy, and administration in institution of national importance, NIT Kurukshetra, and presently in Kurukshetra University Kurukshetra. Professor Somnath, a very simple and straightforward person with a very positive attitude, has visited many countries in pursuit of his research work, including University of Cambridge, UK, Zhejiang Vanli University, Ningbo, China, and has visited countries like USA and Hong Kong. Thank you very much, sir, for sparing your time, for motivating the prize winners, and for the presidential remarks. This forum is greatly obliged. I also welcome our esteemed guest, Professor Suman Beri, who is a role model not only for girls but for all the Indian researchers in science and technology. Professor Beri is one of the few scientists who have presented India on the project CERN. Ma'am's biography, written by Dr. Rajendra Singh, a historian of science and technology from Physics Institute, University of Oldenburg, Germany, is going to be published in March. Thank you very much, ma'am, for giving your precious time, and it is an honor to have you here. The UN General Assembly passed a resolution on 22nd of December 2015 to ensure full and equal participation and leadership of women and girls in the science and technology, and decided that an annual observance was needed to recognize the critical role need to be played by women and girls in science and technology, and established 11th February as the International Day of Women and Girls in Science. Since then, this day has been utilized to promote full and equal access to and participation in the science for women and girls, recognizing the role of women and girls in science not only as beneficiaries but also as agents of change, including in view of accelerating progress toward the achievement of Sustainable Development Goal 6, that is clean water and sanitation. The 7th International Day of Women and Girls in Science focuses on equity, diversity, and inclusion, and water unites us. Today, when February 11th is being celebrated globally in different ways, big and small, members of WIS KUK collectively voiced on equality in science by organizing this event. Once again, I congratulate one and all on this day and hope that together we can bring change to remove underrepresentation of women in science and technology, and together we can find inclusive, sustainable solutions to modern problems and build a better society for all. With these words, I now invite Honorable Vice Chancellor Sir for the presidential address. Sir, please. Sir, please unmute.
Yes,
Yes,
sir.
sir. Yes.
Thank you very
Thank
much,
you.
Professor Neera Raghav. Am I audible?
Yes, sir.
Professor Suman Berry, the expert speakers for today's program. Professor Neera Raghav, Dr. Suman Mehindia, Dr. Pooja Arora, and Dr. Ruchi Gupta, other esteemed faculty members associated with this program and present in this meeting, all participants of the program. First of all, I extend you my warm greetings on the occasion of International Day of Women and Girls in Science. As we know, a number of strategies are being adapted in order to increase the representation of women and girls in science. One of these is to remember the need of the hour by celebrating various significant days. Today, on the occasion of International Day of Women and Girls in Science, I congratulate all of the Istri Shakti, Nari Shakti or Matri Shakti as we usually say, for contributing their worth to science and technology nationally and internationally. Today is the 7th anniversary of the day announced as International Day of Women and Girls in Science. On this occasion, Kurukshetra University Kurukshetra is also associated in motivating the female scholars in science, technology, engineering, and mathematics to explore their capabilities in the field. Statistical data may show underrepresentation of women in various fields of STEM, but their contribution to society is overwhelming and can never be underestimated. Indian researchers from ancient time have contributed a lot to the world, starting from the discovery of zero. In modern science also, contributions of Sir C.V. Raman, Dr. Homi Jahangir Bhabha, Sir J.C. Bose are notable. On this day, we also remember the contributions of various women in STEM, like Ms. Kalpana Chawla, Shakuntala Devi, Dr. Indira Hinduja, Dr. Asima Chatterjee, Dr. Kamla Sohne, and many more. Still, a lot is required by the nation, like our country, to be done in this field. Science and technology of the nation need to be developed. More role models are required. One such researcher is among us today, Professor Suman Berry from Punjab University, Chandigarh, the resource person of today's talk. She has been the part of research team for discovery of Higgs boson announced on 4th July 2012 worldwide. She is one of the 200 scientists from India involved in CERN project. So we are really happy to have you here with us today. So welcome to you on behalf of the university, Professor Suman Berry. Various initiatives have been taken up by government for education of girls as well as in terms of various fellowships only for girls. To promote research by women, DST also has various schemes like Kiran, WAS A, WAS B, WAS C, Power SARM, etc. Maybe because of these initiatives, and other developments, other advancements that take place in the society from time to time, the number of women in STEM has increased in the past significantly. Women in India make up nearly 43% of the total graduates in science, technology, engineering, and mathematics, one of the highest in the world. But just 14%, one four, of them find their place in R&D institutions and universities. The underrepresentation of women in STEM is common globally, but India presents a particularly curious case. Here, the rising education and enrollments of women in STEM are not translating into employability or jobs. This is in stark contrast to developed countries like US, UK, Germany, or Sweden, where fewer women study STEM at tertiary level, but their employability levels are much higher. For example, in Sweden, 35% women study STEM and 34% are employed. That is, nearly all of them are employed in the field of STEM. So this is one gray area that we looked into, and we should try to improve on this particular figure that more and more women
Ma'am, I think some technical issue.
I also said it, right?
So I'm sorry, the network connection got disconnected in between. So I was talking about that very few of the women, they are able to make up to the higher levels. For example, one of the surveys conducted in 2018-19 by All India Survey on Higher Education revealed that just 3% of the women, they enrolled for PhD in science, and only 6% opted for a PhD in engineering. Post entry into the profession, also there is a problem. Retention is also very less, and the break in service is also very common. Maybe because the females, our social setup is like this, that our female counterparts, they have to face different kind of problems and the challenges because of their social responsibilities. They have to sacrifice their time of early career to family and society. So this issue at society level also needs to be addressed. Recently, we have celebrated 30th Foundation Day for National Commission for Women as She the Change Maker. Celebration should not be confined to one day only. The feeling should be inculcated from within. The day is just for remembrance that the word is with you. You just need to put your step forward. As a very popular saying, we all know, for walking 1,000 miles, we need to take out the first step forward. So believe in yourself. You are the best. You have all the capabilities to walk all these 1,000 miles. In the current online offline switchover mode, organizing such events like this gives the students a platform at which they can perform, increase and judge their creativity. I have been made aware that different activities like quiz, poster making, storytelling, and PowerPoint presentations have been organized in this science carnival. Students from schools, undergraduate, postgraduate, and research scholars have participated enthusiastically. I'm very happy that Women in STEM Forum of Kurukshetra University has taken this initiative, because of which approximately 300 participants, they took part in various events organized in this carnival. I congratulate not only the prize winners, but all the participants, as participation is more important than winning the prizes. I also congratulate the organizers, the team of Professor Neera Raghav, for organizing this wonderful event. I'm sure that the female researchers will continue to grow and contribute more towards the academic and research excellence of Kurukshetra University, Kurukshetra, and the university will achieve higher milestones with your contribution. So thank you very much for giving me this opportunity to interact with you on this very important day. Thank you. Jai Hind.
Thank you, sir, for your enlightening words. We ensure you that we would definitely strive to raise the contribution of women in STEM from our forum platform with same enthusiasm and much more. Now, I invite Dr. Suman Mahinga for further proceedings, please.
Thank you, ma'am. So it's time for a prize distribution or announcing of the prizes for different categories and the different events. So for that, to go in the virtual mode, we are hereby sharing the prizes to presentation mode. So let me start with some course in Sanskrit to enhance or boost the courage of the participants for the winning all as well as for the those who are participating in this event. Atme Vedam Sarvam Bharme Vedam Sarvam Atma Deepe Bhava Yat Bhavo Tat Bhavati Sarve Karma Vaksh Vayam Sarvatmani Snehayate Ado. इसका सारांश है कि पूरे ब्रह्मांड में हम आत्मा हैं, हमें सबसे पहले अपने आप में बिलीव करना चाहिए, सब कुछ हमारे कर्म से होता है, तो सबसे पहले कर्म को करने के लिए अपने आप से सबसे पहले प्यार कीजिए और फिर आगे बढ़िए. So with these words, so I am going to announce the prizes category wise and event wise. So our first event was Science Quiz Day held on 22nd of January. And for the category 1, that is for the UG students, we have the first prize for Mr. Pranjal from SG College Ambala Kent, BSc second semester. Second prize for Miss Pooja, B Pharma, 4th semester, Institute of Pharmaceutical Sciences, UTD KUK. And third prize for Mr. Ajit Jha, BBA 3rd SEM, APIIT, SD India, Panipat. And the consolation prize goes to Miss Tanvi, BSc Medical Final Year, Arya Kanya Mahavidyalaya, Shabad. So huge round of applause for the all 4 winners for the science quiz under UG category. Now, on the same day, we had the second category science quiz event for the PG category. And for this category, the first prize goes to Miss Tanu Sharma from MSc Chemistry Final, Dayal Singh College, Karnal. Second prize goes to Mr. Krishan Kumar, MSc Chemistry Final, Department of Chemistry, UTD KUK. And third prize goes to Mr. Aman, MSc Maths Final, Department of Mathematics, Science, third prize. And Miss Yashika, MCA, Department of Computer Science and Application, UTD, for the consolation prizes. So these are the 4 prizes for the category 2 under science quiz event. So next event of the science carnival was on spot poster making competition, and it was held on 29th of Jan of this year, and we have 3 categories for that. Category 1 for school students. So for this, first prize goes to Mr. Bhavesh for class 9 Wisdom World School Kurukshetra, and his topic was clean and green energy. And second prize goes to just a- and second prize goes to Mr. Deepak, class 9 GSS Kamoda, and third prize for Miss Misbah Naz for food and safety topic, and consolation goes to Miss Sophia from class 9 Maharana Pratap Public School. For category 2 of on-spot poster making competition under UG students, first prize goes to Miss Shalu, BSc third semester Arya PG College, Panipat. Second prize goes to Miss Jasmine, B Pharma, fourth semester Institute of Pharmaceutical Science, UTD, KUK. Third prize goes to Miss Payal, BSc fourth semester Dayanand Mahavidyalaya, Kurukshetra. And consolation under this category goes to Miss Harshdeep, BSc first year, GCW, Shahzadpur. So these are the 4 prizes for under this category. Now coming to the third category for the PG student. So for PG student, for the event on spot poster making, first prize goes to Miss Tanu, MSc first sem Department of Microbiology, KUK. Second prize goes to Miss Manisha, MSc second Department of Chemistry, KUK. And third prize goes to Mr. Ashish Sobati from Dayal Singh College, Karnal. And consolation prize goes to Mr. Shivinder Kumar, MSc Technology Applied Geophysics, KUK. Now coming to the event third for the day 3, that is science storytelling competition held on 31st of Jan 2020. And this competition was only for one category, that is for the school students, and different students from the different public and government school in the region of Kurukshetra participated. And first prize for this goes to Miss Samriddhi, class 10th Millennium School, Kurukshetra. Second prize goes to Miss Vanchika, class 9 Government Girls Senior Secondary School. Third prize goes to Miss Sophia from class 9th Maharana Pratap Public School. Another third prize goes to Miss Pragya Pandey from class 12 Geeta Niketan School, Kurukshetra. For consolation prize, we have the 2 winners, Miss Avika, class 9th Millennium Public School, Kurukshetra, and Miss Harshmaran Kaur from class 11th University Senior Secondary Model School, Kurukshetra. Now, these are the 6 prizes under this category. Coming for the next event, that is PowerPoint presentation held on 4th Feb for the category 1 PG student. First prize goes to Miss Yashika Sharma, MCA first semester, first year, Department of Computer Science and Application, KUK. Second prize goes to Miss Aditi from MSc Biotechnology, Department of Biotechnology, UTD, KUK. Third prize goes to Mr. Sargam Singh from MSc first year, Department of Computer Science and Application, KUK. And for the consolation prize goes to Miss Manisha, MSc first semester, first year, Department of Chemistry, KUK. So these are the 4 prizes under this category. And for the category 2 under this is for the research scholar. And first prize goes to Miss Simran Ahuja, Research Scholar, Department of Chemistry, KUK. Second prize goes to Miss Mehak Mittal, Research Scholar from Department of Microbiology, KUK. And third prize goes to Miss Kirti from Department of Zoology, KUK. And consolation prize goes to Miss Sapna, Department of Zoology again, KUK. So these are the four prizes under this event. So huge round of applause for everyone. So it's matter to be to get participated is very important to get participated rather to get win. Participation is always a first step to proceed further for winning any position. So, ma'am, shall we move forward further toward the lecture?
I, th-
Yes, ma'am.
I think we should go forward. Ma'am is there with us.
Okay.
Suman ma'am is
So,
there.
okay.
Yeah.
So after announcing the prizes in different categories under different event of the Science Carnival, it's time to move forward towards the next event, that is the celebration of International Women Science Day. Or for this, I want to start with the thought of that the path from dreams to success does exist. May you have the vision to find it, the courage to get on it, and the presidents to follow it. It is the quote given by Miss Kalpana Chawla, American astronaut and the first woman of Indian origin in space, a highly motivating and kind of spirit she always given to us. And with this, we are move forwarding towards our next lecture, expert lecture. So, as already been depicting by our worthy VC sir about Professor Suman Berry. So, it's my formal duty and my honor to have you, ma'am, with us. And uh, uh, for this, I'm just giving the brief introduction about Professor Suman Berry, ma'am. So she is an inspiring and meticulous, affectionate teacher and been a loving teacher to her students. She is always motivating the young minds with the, with the spirit she is having and with her life that she is bearing. She hold a PhD in 1976 and in the exciting field of cosmic rays. She was the first faculty, lady faculty, first PhD student, first female PhD student, as well as first female emeritus professor in the physics department of Punjab University. She was awarded with the Best Citizen of India award in 2006 by International Publishing House for being the first woman to obtain PhD in cosmic rays from physics department of Punjab University, and for having a large list of publication in the Journal of International and National Repute. She was figured by DST Government of India in top 10 scientists of India in physics based on international comparative performance of India's research base from the Elsewhere publication group. She was also been awarded with the Outstanding Research Faculty Award in Physics and Astronomy from the MHRD survey by Career 360 as one of the top 10 knowledge procedure in India for academic year 2017-18. She was member of prestigious international collaborations like CMS Collaboration Geneva, Switzerland, and D0 Collaboration, Fermilab, USA. She has contributed a significant role in CMS experiment as well as in D0 experiment. She was involved with the research team for the discovery of Higgs boson announced on 4th of July 2012 worldwide and being co-author in the related research papers. She was also involved in the discovery of the top quark, and for this collaboration was awarded 2019 European Physical Science Society High Energy Particle Physics for the discovery of top quark and detailed measurement of its property. And she is also inspiring the students and serving towards the society towards the science. Uh, and she's been the honorary towards the self-realization fellowship, young scientist YSS of India, and a member of governing council, and have been founder vice president of Society for Promotion of Science and Technology in India. She was convener of outreach activity of India CMC collaboration for popularizing science and high energy event. And this is one of the great news for us that the biography of Professor Suman Berry was been now been coming or been coming in a book form in the month of month of March of this year by Dr. Rajendra Singh from Physics Institute, University of Oldenburg, Germany. Dr. Rajendra Singh was known as a historian of science and technology, and written more than hundreds of articles and 39 books dealing with the science and education, and got Nobel Prize related. And Indian scientists, those including the C.V. Raman, he wrote a number of the books related to that. And ma'am, it's very wonder about the ma'am that ma'am has been publishing or contributing towards the 600 research paper with the high H index of 124 and near about 10,000 of the citation. So it's an honor to have you, ma'am, and to motivate our young mind to nurture their future. And as VC sir told us, she is the change maker. So this sentence may belongs to ma'am also. That ma'am is the change maker, being the first PhD student, then the first faculty member, female faculty member, and first emeritus professor in the Department of Physics, and serving the scientific society, not even in India, worldwide also. So with these words, so it's time to start the lecture of ma'am. So over to you, ma'am, Suman Berry, ma'am.
Thank you very much, first of all, for your esteemed Honorable Vice Chancellor, Professor Somnathji, Professor Neera Raghavji, Dr. Sumanji. Thank you very much for inviting me at this forum. It's my pleasure and my honor to be part of this forum, and you have been very generous in introducing me. I think I don't deserve that much, but thank you so much. I am humbled and I'm honored. Neeraji,
and you are always the mentor for me, and it's my honor to introduce you in such.
Thank you so much. Let me see if I can do some justice what you said, and I'll share my screen and start my presentation. Let me see if I can share it properly, and let me share. Do you see it?
Yes, ma'am. Screen is visible. Please go for the presentation mode only.
Is it okay? You
yes,
see this?
It's fine. Yeah, it's
and
fine.
You can hear me also.
Okay. Yes, ma'am.
Okay, so again, thank you to all participants and the organizers for inviting me. So I'll be, since I'm speaking in the forum of women in science and technology, and today is International Day for Women and Girls in Science. So first of all, greetings to all women and all for this special day and inviting me on this special day. And since it is Forum of Women in Science and Technology, I'll be just giving a glance of how the technology which we are using in this Large Hadron Collider, it's marvel of science. Let us see a little bit of it, whatever I can do within this 1 hour. So I'll be just giving you a bit of introduction and a little bit about searching the genetic code of our universe, understanding a little about creation of universe, and discovery of Higgs boson I'll just touch in a minute only. And mostly I'll be dealing with the Large Hadron Collider, which is the world's largest particle accelerator at this time. And this experiment is world's biggest experiment on the Earth at this time. So I'll just take you a photo tour of CERN Geneva, where this Large Hadron Collider is situated, and what research is being done and what we did here. I have been, it was my, unfortunately, I have been part of this experiment, so I can give you some knowledge about what we are doing there. So I start with universe and particle physics. I'll take you a short journey to this infinitely small, basic fundamentals of particle physics, starting from cosmos to the quarks and this experiment, LHC experiment, and the journey continues. If we go back history, when to the ancient Greeks, the basic building blocks were thought to be just earth, air, fire, water. All of us know, everyone.
Sorry, ma'am, to interrupt you in between. Ma'am, please go to the presentation mode.
It is not. It is not in the presentation. To me, it is in its presentation. So
either ma'am, just press F5 from the your.
Just a minute. Let me. I did slideshow. Let me do F5 also. Is it okay now?
Ma'am, it is coming to the slide mode only and not in the presentation mode.
Okay.
Ma'am, just press F5. I think it will work.
No, I have pressed F5 also. I pressed slideshow also. Let me again go to slideshow. Should I go to slideshow again? Let me, okay. It's not coming. Should I do full screen and then it may come? Let me see. Let me try this. Still same?
Yes, ma'am, still same. Ma'am, see on the down toolbar, there is a one button. Just adjacent to that zooming off that, na?
Okay, let me go there and
there it is.
There is. Should I stop?
The third one. Press the third one.
Let me first I stop sharing and then do again, right?
No, ma'am. Just try once here. The button you press at the down toolbar, just go for the third button.
Third button, turn on captions, no.
That is just adjacent to that zooming bar. There it is show 67%. It is adjacent to that. Maybe it work.
Let me see again if it works. Or maybe I can share the whole screen. It as chats window.
Yeah.
Let me stop
share whole screen. Yes, ma'am. Sometimes it's not working on a particular window.
Okay, let me again do. First, I stop sharing and I again see if I can.
Ma'am, share whole screen. Some of the time we are just sharing one window, so either the voice is not coming or either the screen.
I'll share the whole screen now. Your entire screen, okay? And then it would share. No, whole screen it doesn't share. Let me see what you see now. Do you see screen now?
Yes, ma'am. Screen is visible.
And if I do slideshow?
Now it is coming, ma'am.
Okay, so it was the whole screen instead
just do one more favor. There is a one toolbar been coming on the screen. That is the just press the hide. Yes, hide on it.
It is
no in the center. That meet link with the stop sharing with the blue.
Hide.
Okay. Yes,
hide.
Ma'am. Please go.
Is it okay now?
Yes, ma'am. It's perfectly fine.
Fine. Thank you. So I'll again. I'll come to the slide I was showing you. So I'll just take you to a journey from cosmos to quarks, and of course, journey continues with all the. I hope there are students also. So students are there to continue this journey. So in the all of us know ancient Greeks, the fundamental blocks of nature used to be said that earth, air, fire, and water. But with the advent of our knowledge and with more scientific developments, slowly we are here where we are. So in 1900, about 100 elements were known. In 1936, we were back to 3 particles, proton, electron, and neutron. So let us see what's the status of particle physics now at this moment, and how the journey began and where we are and what we understand. Still, our knowledge is, of course, very much limited. So when we talk of cosmology, cosmology means just the study of the universe, its structure, origin, evolution, and density. So let us try to understand how the universe was created and how much knowledge we have at the moment, though it's very limited knowledge. As always, I say that we are perhaps audacious even to attempt studying it. Yet something noble in human spirit urges us to seek knowledge of the universe and our place in it. Universe presents one aspect to philosopher, another to scientist, and another to artist. As Sumanji started with one of the sloka, that we are soul and how the journey of soul has been there. And when we talk of philosopher, if we talk from the thing that metaphysics point of view, we say the whole universe is just a thought of God. God thought of something and he created the universe. But here in this presentation, I would be presenting from the point of view of a scientist, rather from the point of view of a physicist, how we see the universe and what knowledge we have, how it was created. And as I said, our knowledge is still very limited, but it is slowly improving also. And whenever we have any new evidence, it is what usually distinguishes the new knowledge from the old superstition. If we go back in the history, we know there were so many superstitions about this, and slowly how scientists could convince people that what we understand from the science. But of course, we say that astronomy is one which unifies humanity by showing us that we are all in this together. We are facing an unknown, which I personally also feel this, that the word unknown is which describes much of the universe. We know only very 5% of it, rest we are still trying to understand it. We still don't understand whole of the universe. So as I said, we are still learning, but studying the subatomic particles and forces, it gives us a key to understand the simple laws that govern our universe. And the search to understand enriches the human spirit, no doubt about it. And also, it lights up the horizons of the human spirit. And I just like this one sentence, that to learn the truth about the nature of nature for its own sake. And also, the research in pure science is one mark of high level of civilization. And experience has shown us that in the long run, it pays off in concrete, measurable economic and social benefits. Now, why do I say this? Because usually the first question which comes to mind of a common person is that why do we want to do this fundamental basic research? Why to spend so much money to know whether this small particle exists or not and how the universe was created? But you would see when I give you a very brief introduction of Large Hadron Collider experiment that it plays a very vital role in developing the technologies of tomorrow, from material science to computing. As you would see, the particle physics demands the ultimate of performance. We need high-speed computers. We need the technology from the material science latest, and engineering marvel is there, which you would yourself realize when I go through some of my slides here. So we are trying to explore certain basic questions about the universe and about our existence also. All of us, I'm sure there are some students who are attending this talk. When you look at the sky, when you look at the sun, moon, stars, we always wonder that from how they are made and from where they have come. And also, now this is in the digital mode, so I'm not able to interact with the students directly, but usually I ask to the students, when you were young, very young, and you were playing with toys, usually you try to break the toy to see what is inside. Your parents may scold you, but still you would break the toy. And when I ask this question, how many of students or others have broken their toys, the hand raising is almost 100%. So why do we do that? It is just the curiosity of a child to see what is inside with which he is playing. Similarly, physicists are as curious as any one of you. We look for the answers to the questions that people have been pondering since they began to wonder about the world and their own place within it. And it often seems that for every answer physicists find, two new questions arise. That is how the research keeps on going, and the young students would keep on taking this from their older generation. So basically, particle physicists aim to answer two basic questions. One, what are the elementary constituents of the matter? And second, what are the forces that control their behavior at the most basic level? So once we understand this, we think we understand a little bit about creation of universe also. And just to give you an idea, we boast we know many things. In CVP, we are saying so many papers, so much work. But in reality, we know only less than 5% of the universe. Rest is dark energy, dark matter, which we still do not understand. And we are trying to understand this about dark matter, etc. Even with this experiment, LSC experiment also, this is one of the things which scientists are trying to understand. Now, the most accepted theory of creation of universe, which most of you already know the name, is the Big Bang theory. And Big Bang theory says that the whole universe started from one small point, and since then it has been expanding. It was about 15 billion, to be precise. It was 13.7 billion years ago when this universe was created from one single point, and ever since expanding. If you look at this figure, I hope you are able to look at it. I'm starting from one point here, the red circle, and from this point, the universe has been expanding, and we are here after 13.7 billion years. We think that almost from this point to this, we understand how the universe evolved, what happened. But just at the point when it was created, less than 10 raised per minus 45 seconds, we still do not understand. And this is what one of the aim of this LHC experiment is, that we are trying to understand what were the conditions at the time when the universe was created. And we are trying to mimic those conditions in the laboratory and trying to study them. So basically, at that time, it was all in the quark-gluon plasma. But slowly, atoms, particles, different galaxies, some stars, and then finally human beings are here. So let us try to understand a little bit about that. And as I said in the beginning, it was only pure energy, which we call quark-gluon plasma. It is one of the, again, latest field of research which is being done even in LHC also, that finding the quark-gluon plasma tells us that that was the state when the universe was created, immediately when it was created. After 1 second, we know fundamental forces were there, some other particles were created. And after 3 minutes, protons, neutrons began to fuse to form the nuclei of hydrogen and helium atoms. About 400,000 years later, temperatures were cool enough for complete hydrogen and helium atoms to form. And it was for the first time that photons escaped from the matter, and about the same time, light existed for the first time. So light existed for the first time after about 400 or about 300,000 years later, after the universe was created. In particle physics, cosmic rays, you can look at the literature. Many Nobel Prizes have been awarded in this field. And in 2019, Nobel Prize of Physics was awarded for the contributions to our understanding of the evolution of universe and Earth's place in the cosmos. Also in 2011, Nobel Prize was given to the scientist who said that the acceleration, the evolution, how the universe is expanding is not slowing down, but it is fast. It's not slowing down, rather it's the reverse. So these research has given us some clues what we understand as per today. Many more things may come in the future when the young students would be continuing this research. So this is the Milky Way, which all of now, of course, we sleep inside doors. When those who can look at the sky, you can see the Milky Way. So what we are trying to study, I'm just repeating it, we are here after 13.7 billion years, we are going back in creation and trying to understand the creation of universe. So the basic questions are what I have already said. Basic questions are, we want to know what is everything around us made of, how does matter stick together, what is mass, whether there are only 3 dimensions, and what are the smallest particle, are the smallest particle which we know as per today are still smallest, or we may find their substructures also, and where the antimatter has gone. When the universe was created, equal amount of matter and antimatter were created, but now we see only matter, we don't see antimatter. So we would like to understand where this has gone. I will not touch all these points in today's talk. I'll just stick to 1 or 2 or just give you a flavor of this experiment. So when I say what is everything made of, I really mean everything. Everything means whether it is DNA, atom, galaxy, person, table, chair, where you are sitting, everything. So let us see now. Your Professor Neera, she is from chemistry. If you ask the chemistry expert what is everything made of, I think their answer is that they see that everything is made up of periodic table, starting from the basic hydrogen atom going up to the highest elements. But I would just now in 1 or 2 minutes will tell you for physics, the periodic table is a little different. So we would answer this question in a little different way, that what everything is made of. This all of us know, even the school students know that earlier it was thought that molecules are the smallest particles. Then we came to know no, molecules are made up of atoms. Then further research showed us that no, atom is not the smallest. Atom has nucleus, it has electrons. So at one point, scientists thought they were quite satisfied that we know, okay, atom is not smallest, nucleus is there, electron is there. But physicists wanted to know a little more whether nucleus has structure, and it was found, yes, nucleus has protons and neutrons in it. But still physicists were more curious to know, is the proton smallest or proton has substructure? And it was found by the research that proton also has a substructure, neutron also has a substructure, which we call quarks. Most of you must have heard the name of quarks, and some of you may not have heard the name of quarks. So there are 6 quarks, but in proton and neutron, there are 3 quarks in each, 2 different types of quarks in proton and neutron. And if I give you a little bit of idea of the magnitude of this particle quark, it is 10 raised to the power minus 18 meters. So this is the area, this is the size where we are doing research, where we are finding particles of this much size, and you can see how difficult it would be. Atom and nucleus, all of us, I'm sure all of you know the size of atom, 10 raised to the minus 10 meters. Nucleon is 10 raised to the minus 15 meters. Quark is 10 raised to the minus 18 meters. Much, much thinner than your hair. So we are trying to do research in this area, which is why it is complicated and why it is so such a big collaborations are required, because going up to this level of size is a challenge to work on. So again, the advantage and disadvantage of giving the talk in digital form, usually I would like to ask to the students some questions, because we know if you want to see at, let's say if you want to see at moon, you use telescope, you use radio telescopes or optical telescopes. But if you want to see some distance nearer to that, then we use binoculars. If you want to see quite closer something, let's say looking outside your window, some trees or something, you can use a naked eye to see that. If you want to see still smaller sizes, smaller distance, you use binoculars. But if you want to go to lower size, and I'm sure all of you know that microscope is the instrument which we use to see the smaller things which it magnifies. So microscope, you can see up to 10 is per minus 6 meters, and with electron microscope maybe of the nanometer. But if you want to see still the smaller size, what do we do? I want to ask this question, but I'm answering this question myself on your behalf, that if we want to go to the distances of the quark or the 10 to the minus 15 meter, we use accelerators and detectors. And Large Hadron Collider is one of the accelerator at this time which can accelerate the particles to the highest energy available at this time. We are colliding two protons at about 13 TeV. Finally, it would be 14 TeV. That center of mass energy, TeV is 10 is per 12 times electron volt, which we measure the energy. So it is a very high energy, and to accelerate the particle or the proton to high energy, we use accelerators. And Large Hadron Collider is one of the latest high energy producing accelerator, which I'll be giving you a glimpse of it. Sumanji, my light power has gone. I hope my inverter works for some time. Otherwise, if it is gone, I'll switch on to my mobile or so. Okay?
Sure, ma'am, sure.
Okay. I hope it comes soon. It usually doesn't go at this time.
Okay,
So the matter particles are made of now proton, neutron, electron, neutrino. But proton, as I said, has a substructure. This is there are 6 quarks, and up quark and down U denotes up quark, T down quark. So proton is made up of 3 quarks, neutron is made up of 3 quarks, and electron at the moment, as per today's knowledge, it doesn't have any substructure. And then there is a particle neutrino, which doesn't have substructure. So our basic constitutes become quarks, and electron and neutrino, which we combine, call them electrons. So I come back to what periodic table physicists have. So before that, as I said, I talked about proton, neutron, electron, but we are also having neutrinos in here in the universe. It's not only quarks and electrons, and neutrinos are coming all the time. Even at this time, neutrinos, lots of neutrinos are passing through your body. Every centimeter square of Earth is crossed every second by more than 10 billion neutrinos, which are produced in sun. And from sun, they are crossed even at this time when you are sitting indoors also, neutrinos are passing through your body. But we need not worry, because our bodies are transparent. Neutrinos don't, they're very weakly interacting particles. They just pass through us. They can pass through the Earth without interacting a number of times. So we need not worry, but it's one of the latest research topic also studying about neutrinos. So now we come to what everything is made of. So in the first, we have 3 families or 3 generations of the matter, which we call. In the first generation is the ordinary matter, which I just said, protons and neutrons are made up of either up or down quarks, and we have neutrinos and electrons. So electron and corresponding neutrino, and these 2 quarks up and down, they make first generation. In the second generation, we have other 2 quarks. C stands for charm, S stands for strange and charm. So, and one particle muon and neutrino, again, these are under the category of leptons. In the second generation particles, we obtain from the cosmic rays. First generation is which we see in the ordinary matter. Second generation, which we get from the cosmic rays. And the third generation, the last 2 quarks, top and bottom, or truth and beauty, and the tau. These can be produced only with the help of accelerators. So we have three families, three generations. Sumanji started with the sloka from Gita. So if you know, in Hindu mythology, we have three generations, Brahma, Vishnu, Mahesh. So we have three families, three generations of our particles which we have, which everything is made of. So for physicists, the periodic table of modern physics is we have 6 leptons, 6 quarks. I have already named them: up, down, charm, strange, top and bottom, and 4 forces. In particle physics, we take 3 forces, but in the universe we have 4 forces: strong force, electromagnetic, gravitational, and weak. So our periodic table is this: 6 leptons, 6 quarks, 4 fundamental forces: strong, electromagnetic, gravitational, and weak. So I just leave this. So this is just for school students. I don't know if some school students are still there after getting their prizes. That how the atom is. For example, if we want to make helium atom, we have 2 protons, 2 neutrons, and if we have electrons going around them, it makes a helium atom, right? And but if you have billions and billions of these helium atoms, this is what our universe is: galaxies, stars, so many galaxies. Our own galaxy, in which our sun system is there, but there are number of other galaxies also which make the universe. So starting from basic hydrogen, helium, the whole universe is there, and these are the basic fundamental forces. I will not talk about them. For particle physics, we take 3: strong force, weak, and electromagnetic. And gravity, still we have not been able to unify in our particle physics. So I don't know. Sumanji, are there some students also, so I can tell what we mean by force?
Yes, ma'am. Yes, ma'am. There are some students from that particle physics also.
Oh, okay. So for particle physics, they know that when we talk of force, classically force means just interaction of electric field from one particle to the which is felt by the other particle. But when we talk of the quantum mechanics, then what we mean by force is the exchange of quanta. If there are 2 charged particles, force, how we define the force is that there is exchange of quanta from one particle to another particle, and this exchange gives us the concept of force. For each force, whether it is strong force, electromagnetic force, or weak force, the quanta is different. For example, for electromagnetic force, quanta is photon. And similarly, if we are talking of strong force, it is gluon. If we are talking of weak force, there are other particles which are known as W and Z particles. So quanta of exchange is different for different type of forces, and that is the quantum mechanical, how we define the force from the quantum mechanics point of view. You know, I said basic fundamental particles are only what I said in the periodic table, but overall there are, till now we have been able to find a number of elementary particles, quite a large number. And I just like this quote which I would like to share with you. Nobel laureate Fermi, everyone in physics knows, and his student was Leo Lederman. Both of them were Nobel laureates. Fermi was telling his student that, young man, if I could remember the names of these particles, I would have been botanist. But since we can't remember, so we carry with us a particle data book we call our Bible also, in which all the properties and all the particles are listed. Someone has kept me telling how much time I can have more. So in particle physics, when we combine our knowledge of forces and the basic particles, so physicists, they would like to explain the behavior of these particles, how they interact. This everything is given, which we call in a model, standard model, which is the most widely accepted framework, which is believed to explain most of the world we see around us. And in standard model is the same thing what I just said: 6 quarks, 6 leptons, and the exchange particles and the 4 forces. The only missing piece in the standard model was Higgs boson, which is known to be one of the, which as mentioned by Sumanji and your Vice Chancellor also, we observed the Higgs boson in 2012, And this is known as one of the greatest achievements of the 20th century science, because it's very interesting to know. To find the smallest particle, we know we need a biggest experiment on the Earth to see that. Isn't it interesting? I find it very interesting. So, but I'll just spend 2 minutes, not details at all at this time. What is Higgs boson and why was so much hue and cry, and why was so much international thing about this, that when Higgs was discovered, it was international news and people were very happy. Why was this so much? What is Higgs boson? And why were we so anxious to observe it experimentally? This particular particle, in public known as the God particle, this was proposed by Higgs more than 40 years back. But we could not see it experimentally till 2012. So why it took so much time and why it was useful to find it, I'll just mention in 2 minutes, not going to very much details. So there was, as I said, it was theoretically given that Higgs boson should exist. It was given way back in 1964, and we confirmed in 2013, but observed in 2012 also. And because this is a particle which was thought to give mass to other particles, and we know that others mass is there, but from where the mass is coming, why someone is heavy, why someone is not having that much mass, that how any particle or how it acquires mass. So theoretically they were able to explain that we can explain from where the mass is coming if we say there is some particle, Higgs particle, existing in the Higgs field, and this field was present when the whole universe was created, and it is still there. So that was the very interesting thing. And so I will not go into. So in 2013, the Nobel Prize in Physics was given to these two gentlemen, this is Engle and Peter Higgs. There were three actually scientists who had predicted, but Nobel Prize is given only to the living persons. And in 2013, they were awarded jointly the Nobel Prize for their theoretical discovery of mechanism that contributes to our understanding of origin of mass. Now, we were very happy when they got the Nobel Prize. Why were we happy? Because if you see in the citation, the last line is that this was they were given Nobel Prize because it was confirmed through the discovery of predicted fundamental particle by ATLAS and CMS experiments at CERN's Large Hadron Collider. And I am part of CMS experiment, and all the collaborators of ATLAS and CMS were very happy when they got Nobel Prize, because our name of our experiment is there in the citation. As you can see, just to give you a glimpse of the day when this Nobel Prize was being announced, I was there in the CERN by chance. This is our one of the buildings of CMS experiment here, and where collaborators sit, offices of CMS and ATLAS. And when this was announced, you can see how people are very happy that we have got the Nobel Prize. I was standing somewhere here. You cannot see me, but I was very much there. So this is the director of CERN. He was congratulating all the collaborators because Higgs and Engle got the Nobel Prize. They got the Nobel Prize because we could observe this particle experimentally. That is the reason we are happy. You can see, this is one of my first CMS PhD student. He is now associate professor in Delhi University, and we were there at that time when Nobel Prize was being announced. So this is just to show you one of the picture. This is one first Higgs particle which was seen in the interaction of colliding two protons at a very high energy. Then this is actual interaction which took place and in which Higgs was seen. I would tell you it's a very difficult, very, very complicated analysis to find, because there would be billions and billions of particles which come out when the two protons are colliding at that energy. And when they collide, millions of particles may come out, But out of millions of interactions, there's only one interaction in which Higgs is there. And that is the art of doing analysis, state of art of doing complicated analysis, to separate that event which has Higgs boson in it from other events. They mimic like that, but they don't have. So this question arises in any common person, that why we are spending so much money, so much power, so much manpower, so much time to find this one small particle which we are calling as God particle or Higgs particle. So the same question was in the committee members who had to finance this project. So in the UK science minister, his name was William Waldegrave. He gave a challenge to physicists that please answer me, what is Higgs boson and why do we want to find it? And he said, I don't want a long answer, just give me a small brief answer why we want to find it and what is Higgs. So this is known as Waldegrave challenge. I'll just tell you what he said and who won the prize for giving him the satisfactory answer. So David Miller of UCL US, he won a bottle of champagne for giving the answer which satisfied the UK science minister. So that was it. He said, supposing you imagine a room which is full of, let us say you imagine a room full of what you are sitting, students and so, or any persons, and supposing the prime minister walks in, what would happen? Usually I give an example that when I am speaking and if prime minister enters, you would stop listening to me, you would stop even looking at me, and everyone would start going and everyone would go around the prime minister. You see what has happened to him. He is surrounded by a cluster of people. Now this is exactly analogous to generation of mass. You know, all the mass is generated. So Higgs has the same property that when those who are near to him, it can impart more mass to that particle, and those who are relatively farther, they would be imparted less mass. So we can explain from where the mass comes, why some has more mass, why some had less mass, depending upon their interaction and their closeness to the Higgs. In the Higgs field, they acquire mass. So this was the example by which he was convinced, and that's what. So I'll leave certain things here. Why we need a very high energy accelerator to find Higgs? That is one question which comes to mind to the students also and to other persons. So the simple answer is, supposing we want to enter inside the proton to see how the quarks are interacting. Only from the interaction of quarks, if we want to see whether in some interaction we can produce Higgs boson or not. Now, as I said, Large Hadron Collider is a collider which accelerates the proton to a very, very high energy. How does it do? To see the proton inside, we should have a probe which is smaller than the size of the proton. And we know the size of proton is very small. So we would need a probe which can go inside the proton and collide in the collision, see what comes out of it. So I have already said that we want big experiments to see the smallest particle. And this experiment is being done in CERN. Sumanji, I can take 15 minutes to explain LHC?
Yes, ma'am, sure. It will be good for us.
So I'll just tell very briefly, CERN, I hope, again, I can't ask question to the students, which I answer myself. CERN stands for European Center for Research in Nuclear Physics. This is an international laboratory situated in Geneva, Switzerland, where a number of countries, more than 48 countries, are part of this collaboration in which we are doing experiment at CERN. There are many states. Let me give you a little bit more. You can see a beautiful Zora Mountains of the Switzerland, where this experiment, Large Hadron Collider, is situated. And again, I usually ask this question, do you know, every one of us these days are using www. You are listening to me because of www. So where was it? Webb was born. It was in CERN by this person, Tim Lee. He was the one who had given this idea of using web, and web was born in CERN. And this was because particle physicists are situated in different countries and they want to share the data, they want to share the analysis. So this was the need of particle physics. We have now whole of the universe, all world, they are using www. Even students, small students of school, they use. So in the CMS collaboration, in which I am and my university, Punjab University, is also part of CMS collaboration. In India, we started with 4 institutes in CMS collaboration: Delhi University, Punjab University, Tata Institute of Fundamental Research, TIFR, Bombay, and BARC, Bhabha Atomic Research Center, Bombay. And now there are 9 more have been added. So about 13, 14 universities and institutes are part of this CMS collaboration. And in this collaboration, now this is a relatively old slide, there are more than 45 countries, more than 2,000 physicists and engineers, and I am one of them. So I'll just take you a photo tour of Switzerland if you want to do in this season also. So this is a Large Hadron Accelerator Complex, what you are seeing as from the air view. And now I come to where the Large Hadron Collider is situated. I am sure, I hope all of you can see this red ring. This ring is a 27 kilometer circumference. It is a tunnel which is 100 meters below the surface of the Earth. And in this tunnel is situated the Large Hadron Collider. You can see just a very small portion of this collider. This is situated in whole this 27 kilometer circumference tunnel, this Large Hadron Collider. Okay, so I'll tell you further. If you see again the air view, this is the Geneva. In this, half of this lies in, just a minute, there is an aeroplane. Half of this lies in Switzerland, half of this lies in France. So our experiment, our CMS is in where the detector CMS is, that lies in the French side, and half of it lies in the Switzerland. Our CMS office, which I showed, that is in Switzerland. So now, if you can see, in the Large Hadron Collider, one proton beam travels in clockwise direction, other proton beam travels in the anti-clockwise direction. Both proton beams protons are accelerated to a very high energy, 7 TeV each, 7 TeV. That means 7 eV 10 raised to power 12. And this is, the two beams are made to collide at certain points. There are main 4 points where these experiments are situated, detectors are situated. So one proton beam coming from this side, other coming from this side, made to collide at this point, and out on this point, a detector is placed. Around this point, the whole detector is placed so that whenever they collide, whatever comes out of this interaction, we should be able to record and collect the data which we analyze afterwards. So the two experiments, CMS and ATLAS, they are the general purpose experiments which were designed to look for the Higgs boson or the God particle. And these two experiments, ALICE, this was designed to look for heavy ion particles, for example, the quark, gluon, plasma, etc. And another experiment, LSC-B, was designed especially to look for B quarks. So these are the basic. There are other small experiments also, 2, 3, but main 4 big experiments which were designed. So they are placed. I would show you the size of the detector is almost 5-storied building. So this whole detector is placed at the point where the 2 proton beams are made to collide and then detect, and then out of millions of interactions, one interaction which gives us the Higgs boson. If some of you would like to know why we call Higgs boson as the God particle, should I tell Sumanji this also?
Yes, ma'am. Briefly, you can please.
So actually, we became famous because of the name of God particle, because the common person is not very much interested about Higgs boson, but for God particle, everyone is interested. So when we said we have found the God particle, it was very, even the media and the general public, they were very much interested to know what is God particle. This is one of the property, as I said, which gives mass to other particles, and one of the very mysterious as well as important property. Now, this is something, finding this particle was as difficult and as a piece of cosmic puzzle as finding God. जितना मुश्किल गॉड को फाइंड करना है, उतना ही मुश्किल था गॉड पार्टिकल या हिग्स बोसोन को एक्सपेरिमेंटली देखना. So that was the reason, that is one reason, but main reason why it was accepted even in the scientific community to give it the name of God particle was that, if you remember, I just had named one Nobel laureate, Leon Lederman. He got Nobel Prize and he had worked
मैम
on...
कैश प्राइज कब मिलेगा?
हाँ जी,
कैश प्राइज कब मिलेगा?
यश, आप बाद में बात करना, अभी आप लेक्चर का...
Okay, so this was for you.
Right.
So I think I should finish quickly in 10 minutes or so, okay? People, it is already, no, it's still 40 minutes. I can take 10, 15. So Lederman was writing a book and he was talking to the publisher that people have been working for so many years and spending billions of dollars and so much money to see Higgs boson, but God damn it, we are not able to see it. The publisher said, sir, if you say God damn it, no one is going to read your book. He was writing a book that if universe is the answer, what is the question? So publisher said, sir, if you call it God particle, people will read your book. If you call God damn it, no one is going to read. So they proposed this to Peter Higgs and Higgs agreed. He says, I don't mind if you call Higgs boson as the God particle. So that is how the name God particle was given to it. And it represents, as I said, because it is as amazing as the creation of God. So this was appreciating the God's universe also. So the name God particle came. So let me now very briefly in 2 minutes, 3 minutes tell you what we do to see this particle. Earlier, when we used to see smash things, if you can see this cartoon, two scientists are holding two bricks in their hand. They are going to strike one brick with another and see what comes out of it. And now if you can see this, a few years back, the accelerator, the maximum energy available accelerator was used to collide. Let us say these are two particles. If they are made to collide, that you can see what happens. So it has broken into small parts. You can see the small parts going around. And now with the advent of time and with the advent of development of the technology, we could have accelerator which can give us more energy than the previous one. So when we had, if you can see this bar here, earlier energy was up to this point. Now if we can have energy up to this point and again collide these particles, see what happens. Now again, I answer from your side, from the student's side, that the difference between the previous and this slide is that now these blocks are smaller in size. So that means we can study more minute details when we are colliding two particles, what comes out of that collision. Okay. So once this was achieved, people were happy. But that is not the end of story. We, particle physicists in LHC, we are using very extensively the Einstein's relation, which is known to everyone, that E equal to mc square. Here what we are doing, we are converting energy to mass. Why I am saying so, it would be clear in a minute to you. Supposing we collide two oranges, what would happen? This is you would say it's a silly question. If we collide oranges should come out. But no.
So, ma'am, orange juice will come out.
Yes. 50% students reply that orange juice comes out. But physics, I hope the physics teachers who are sitting here, physicists are related crazy persons.
Yes.
For us, let us see what answer we would give if we collide oranges. See the physicist answer. So you have seen out of oranges, 2 bananas have come. So this is exactly what we are doing. We are colliding 2 protons, and I am sure all students know, at least science students know, the mass of proton is approximately 1 GeV, 938 MeV, but 1 GeV. So we are colliding 2 protons, 1 GeV, 1 GeV proton, and the mass of Higgs boson is 125 GeV. So the simple question is, by colliding 2 particles of 1 GeV, 1 GeV, we are getting 125 GeV. How? We are using E equal to mc square. That is why we are accelerating the protons to a very, very high energy so that we can convert that energy to mass of the particle which we want to generate. Okay. So just see, if you collide now we have, at present, we have accelerator of this much energy available. You can see this whole bar. We started from this much energy, this much, and now this whole bar is red. That means we are having energy. So when we collided these 2 particles, you can see dinosaurs here. So we have used E equal to mc square. So the collision energy has been used to create something new that did exist but does not anymore. This is exactly how the Higgs boson is being created. Just look at this very carefully now. This is the last this animation I'm showing you. So see what has happened. Dinosaurs appeared and they disappeared. And what finally you are getting? Just these small blocks, these 4 small blocks. Dinosaurs appeared, disappeared, and finally you are seeing. So that means we see the resulting particles. So from these particles, we have to find out, analyze it, that whether this is a Higgs boson or something else. So we have to be like detective to see at the evidence, and from the evidence we see what has happened. So this is exactly how the Higgs boson is being produced and how we are observing Higgs boson. And when we collide 2 particles, this is not just some drawing drawn, it is all the particles which are coming after collision of 2 protons. And out of these so many particles, we have to see which one is Higgs boson. How do we see this? So I'll take just 2-3 minutes to tell you about how we see that. We need accelerator. First thing, we need accelerator to accelerate the particle to a very, very high energy. Second thing, we need detector to detect particles which come out of the interaction. Third thing we need is the computers to collect the data, store the data, and then keep on analyzing. It takes years to analyze the data, what we take in a month or so. And fourthly, we need the young students who are sitting here, young students to analyze the data and to take this research forward. So I'll just skip all the things. I'll just, in 4 slides, tell you about Large Hadron Collider. You can see this is in a tunnel. These are the bending magnets. These magnets are going around the 27-kilometer circumference tunnel. And just to give you an idea how much energy it is accelerating protons, all of us know the car battery has 12 volts. If you have 1.17 trillion car batteries, जितना acceleration, जितनी voltage 1 ट्रिलियन कार बैटरीज को होगी, उतनी एनर्जी का प्रोटॉन लार्ज हैड्रॉन कोलाइडर एक्सेलरेट कर रहा है. और एक्सेलरेट करने के लिए जो तो फिजिक्स के स्टूडेंट्स हैं, दे नो दैट यू नीड इलेक्ट्रिक फील्ड टू, इफ you pass any charged particle between electric field, it gets charge, it gets energy up to, depending, it's a potential difference. So here we need a very, very high electric field cavities to accelerate protons to a very high energy. So this is situated 100 meters below. Particles are accelerated to the speed of almost light, 99.99% speed of light, and 2 beams, one goes clockwise, other goes anti-clockwise, and they are made to collide. So this is a place where hottest reaction even in our galaxy, they happen when we collide 2 protons at that high energy. And the temperature is, if you can look at the screen carefully, the temperature here is, if you count these zeros, it is 6, 9, 12, 16 zeros. 16 into 10 is per 16. That much is the temperature when we collide two protons at that high energy. Violent collision. And these are the particles on the right hand side, what you are seeing. These are the particles which are coming out after collision of two protons at this much energy. Now, your question should be, if this temperature is so high, then how do we survive? Let me give you an answer. In a second, I'll give you the answer. It is, as I said, protons are being accelerated at the almost 99.9% speed of the light. So this is the fastest racetrack. First, I said it is the hottest place. Second, I am saying it is the fastest racetrack. And because protons can move at the almost 99.99% of the speed of light. And third, it is the emptiest space, more than even emptiest space what we have in the solar system. So usually students ask the question, why do we need that much vacuum? And creating this much vacuum is a very, very difficult and complicated experimental reason to do that. But we need vacuum. We do not want anything else to interfere when the two protons are colliding, because we want to see some specific particle. We don't want anything which comes outside and interrupts what we are trying to see. So the temperature, now I said hottest place. Now I am saying it is one of the coolest place in the universe. Coolest bhi kitni hai? Temperature is minus 271 degrees Celsius. Minus 271. Why we need this much? Because otherwise the temperature I showed you in my previous slide, everything would burn. We won't be there even. So we have to maintain the temperature to minus 271 so that we are able to observe what we want to observe. And again, this is a state of art, how to maintain this minus 271 temperature. These are done by superconducting superfluid liquid helium. These are the cylinders in which this superfluid liquid helium is contained, and this is what is circulated where the interactions are taking place, so that this temperature is even colder than the interstellar space, hottest than the space. So we are having that much heat produced when protons collide, and we have to cool them with this. So that is why it is being called the biggest experiment. You are seeing how much hot it is, how much cool it is, how much fast protons are traversing when they are accelerated. So, just a minute, there is an aeroplane. So these electromagnets which are in the tunnel, because it is 100 meters below the surface of Earth, they have to be lowered down. So they cannot lower down all the magnets together. They were lowered down one by one, which you see on the left-hand side. A very special crane is used to lower the magnet so that it is not in between. It should not be destroyed, any part of it. So very careful, a very special crane was used to lower this magnet 100 meters below the surface of Earth, and then all the magnets were assembled in 27 kilometers. As I said in my first slide, that indirectly we are helping technology development, we are helping the society, we are helping the other persons by the technology we are using. This crane was specially manufactured for this purpose, but later on, Pandubi, which goes under the sea, that was drowned and it had to be pulled out. So no other crane could do that, and this crane was used. So computing, which we are using now, everyone is using. So indirect uses of the finding fundamental particle are that the technology is also being developed side by side. We use 8.3 Tesla magnetic field to keep the protons in the circular track of 27 kilometers ring which we have. So we need a very high field, magnetic field, to keep them in the circular path. We need a very high electric field to accelerate the protons, and this is the state of art, and that is the way technology, I am saying, marvel of technology to construct this Large Hadron Collider and also to construct the detectors which detect these particles. So this is just to show you a set of radio frequency cavities which are accelerating field of 5 million volts, and the electricity which is required is almost, you can full Geneva, पूरी सिटी में जितनी इलेक्ट्रिसिटी यूज होती है उतनी इलेक्ट्रिसिटी हमें जहाँ पे हर रोज चाहिए to accelerate these particles. So just to tell you, gives you a glimpse of the tunnel when it is open, when the experiment is not going on, collisions are not taking place, it is called shutdown period. Then public and others are allowed to go in this tunnel and see. So this is at that time when it was open days, we call, when the experiment is not taking place, but we can go and see if we want to do something with our detector, repair it or replace certain things. So this is our Indian scientist, Archana Sharma, who is scientist in CERN there. And this is in one of my visits when I was visiting CERN during that time. So I just give the final thoughts on the technology. LHC detectors are the most complex scientific instruments ever made. And this detector has about 100 million individual sensors. Typical digital camera of sun, if you have 6 megapixels, is nothing in that. This digital camera or detector here takes about 40 million times more than every second pictures it can take. So that is about collider. In just 1 minute, our contribution to the detector, I'll tell and will not talk about anything about detector. So earlier, this is what I'm showing here is, this is in the grounds of the CERN laboratory in Geneva, Switzerland. This is bubble chamber, which earlier we used to use as a detector to detect particles. And now if you see the CMS detector, how complex and how big the CMS is, it is about 5-story building. And it, as I said, it records signals 600 million proton collisions every second. In 1 second, 600 million proton collision is it detecting. And I will, as I said, I'm not about the detector, but this you can see some scintillation counters which are part of this detector. They were fabricated here in Chandigarh, Punjab University, and in Bombay TIFR. We fabricated these scintillation counters and they are part of the detector now. They were shipped to Geneva, Switzerland, and they are part of it. So this detector is a CMS detector in which we were participated in hardware also. Its weight is 12,000 tons and it is, as I said, height is about 5-story building. It took about, it is just one small portion, I'm just showing you to give you a feel of why we are calling it biggest experiment. It took 20 years to design and build this detector. And it is, as I said, like a 3D camera taking 75 million pictures per second. So this is what I was referring. This is what we fabricated here in our university and in TIFR Bombay. And they were all installed in one part of the detector, which is we call as the CMS detector. I haven't talked about that much. So all these steel things you are seeing, they are our contribution, Indian contribution. And one other contribution is in here in the, which was by Delhi and BRC. They had some shower detectors here. So this is again part of that. I'll just skip everything. This is our, she was our, from TIFR, our spokesperson at that time of CMS collaboration. And these are our offices there. So when we were installing our detector, which we fabricated in India, so these are, at that time, they were my research scholars. Now both are, she's in US, she's in Geneva, again, CERN, Switzerland, doing postdoc. She's also working in US. So they were doing PhD students at that time doing with me. So what we fabricated here, it was our responsibility to install it there, going to CERN and installing the part which we fabricated here. So this is again, the other experimentalist, he's from Calcutta and she's from Delhi. And we were at that time installing our detector there. This is again at the same time when we were participating in detector installation. This is again the same scientist, Archana Sharma. She is permanent scientist in the CERN and doing very good. She's at a quite good high position there and doing very good work in one of the detectors in RPC and GEM detector now. These are again students and faculty from Delhi, Calcutta, and Chandigarh. Suman can recognize Vipin Bhatnagar here. He was my first D0 PhD student, and now he is professor and in charge of our high energy physics group here in Punjab University Physics Department, and others are all research scholars at that time. So this is what I was saying. This is 5-storied building, and this is the size of the detector. That's why we are saying it's the biggest experiment. So let me not go into details of this. I'll just skip everything and conclude my talk here. So when we found Higgs, it was published in Physics Letters, the observation of Higgs, discovery of Higgs, and the number of authors were more than 1,500 who participated in this discovery, and I am one of them. And to work on these big detectors, one should know mountaineering also. Only then one can work on these detectors. And I think my talk will not be complete if I don't even for 1 minute talk about the computing which we need for analyzing the data and finding and observing and discovering the Higgs particle or the top quark earlier. So the data which is collected is almost equivalent to volume of 10,000 encyclopedias. To give you just a very just an interesting example, if we calculate, if we store this data on DVDs, then, and if we stock the DVDs, then the height of the DVDs would be more than the height of the Mount Everest. Mount Everest की तकरीबन 10 किलोमीटर हाइट है. तो अगर आप CDs पे डाटा अगर अपना रखते और उनको स्टैक करते तो it would have been about 15 kilometers. So more than height of Mount Everest would be the data collected in 1 year even. And you can now imagine, if you have to analyze this data, how complicated the analysis is, state-of-art analysis, and just an interesting thing, not a serious thing, but if you were to view these DVDs, it would take you 40 million years to watch the movies. So that is what we are doing here. That's why we need 2,000 physicists and engineers to work on this collaboration. And that is about LHC. And in LHC, we are also, scientists are also working to understand about antimatter. As I said, when the universe was created, equal amount of matter and antimatter were created. Now we see matter, we don't see antimatter, but it's good we don't see antimatter. If we see antimatter, for example, if there's one person, there would have been the anti-person of that, and looking almost similar, and by any chance, God forbids, if they were to meet, then what would have happened? They would have disappeared. So though we say it's good we don't see antimatter, but still we are very curious to know the mystery of antimatter, where it has gone. And scientists are studying in LHC this problem also about antimatter and dark matter, dark energy, etc. Why nature preferred matter over antimatter, we don't know. Theoretically, there are many articles on supersymmetry and supersymmetry particles, but experimentally at the moment we have not been able to see any supersymmetric particle. Maybe in future, if we see, we may be able to tell something about dark matter also. So let me conclude my talk that truth is there, that CMS experiment at Large Hadron Collider brings physics into unexplored territory. New processes and particles could change our understanding of energy, matter, and space. We can learn about basic forces that have shaped our universe since the beginning of time and the time to come. And of course, all you young students and faculty who are sitting here, you could be part of it to give us this understanding, to add to our understanding what we do understand now. And the official announcement of discovery was made on 4th July 2012. You can see in the all different parts of the world, This is in CERN Geneva. This is in Australia. This is in US. So when it was announced that, yes, we have seen the Higgs boson or the God particle, people were very happy. And at that time, Higgs and Engle, they were present in the CERN room where it was auditorium where this discovery was announced, and you can see these two gentlemen here. And there was a very, very huge reporting by the press of this discovery of Higgs. There were headlines about, and there was that Hawkins lost bread, etc. So there were about 1 billion people who were watching TV when this was announced. About 17,000 articles appeared in different papers, publisher and publications in more than 108 countries reported on the same day when Higgs was announced. And it was a world media, as you can see from here, in all media, this news was there. It was a big breaking news that, yes, we have seen the Higgs boson experimentally, which was theoretically given more than 40 years back. So this was a break. That is why it is said the biggest achievement of the 21st century. And this is worldwide audience. You can see how many people at that time were visiting. And the same was true in our own university physics department. You can see all the media person, TV persons were in the department. These are some of the research scholars. And I was traveling on that day from Geneva to Chandigarh, and from Delhi airport to Chandigarh, throughout, after every 20 minutes, half an hour, I was getting a phone call from the TV persons or the media persons then when I am arriving, and they were there, standing there with the cameras to report this discovery. So you can see again the different, this is again our Punjab University group here. And so Higgs has been found, and you have to be patient for some more time, and we'll learn more about properties of Higgs, and beyond standard model physics also is being done very actively in the CERN. So let us conclude that LHC is the largest, most complex, challenging particle accelerator in the world, and it promises to open up unreachable areas of particle physics. And we say that just as Albert Einstein, with his theory, it really revolution was there in the physics. So we could say that we are at the threshold of new revolution in our understanding of the universe with LHC, Large Hadron Collider Experiment. And we believe that we have captured God particle, which gives mass, and it holds the physical fabric of the universe together. And I'll finish with the quote of Newton and one quote of Einstein. Newton said, "What we know is droplet, what we don't know is the ocean." And this whole ocean is for you young students to explore and find the new gems out of the ocean. He said, Newton also said, "I didn't know, I was very much satisfied with the very beautiful pebble. I didn't know gems are also there in the ocean," which you students and the young faculty can find out. This is a Geneva lake, and you can see So at that time, a very small mobile I had taken the picture of Geneva Lake. This is a very famous fountain on the Geneva Lake, which you can see even from the air when you are traveling by air and from the aircraft also. It's a very high fountain there. This is just a view of the CERN offices and the very beautiful mountains on the French side here. This picture was taken from inside my hostel room, inside the window rather, from the mobile, just to show you what CERN looks like when we stay there. The beautiful mountains here in the CERN. And let me end my talk with the quotation by Albert Einstein. I'm using this quotation for last 20 years in every talk. This is always my last quotation. This is that 100 times, every day, I remind myself that my inner and outer life depended on the labors of other men, living or dead, and that I must exert myself in order to give in the same measure as I have received and am still receiving. Thank you very much.
Thank you, ma'am. Seriously, a wonder lecture or a very inspiring lecture, and how beautifully you brief us about the existence of universe and the physics periodic table, that is the existence of the quark. And I know many of them are been very knowing about the fact of the quarks, but they're still to learn about much and much about that particle physics. And the small tour towards LHC, CERN, Geneva, virtual tour given by you, ma'am.
Virtual.
And it's, yeah, seriously, it's virtual tour, and it looked like we have been there only. How beautifully you explain and you involve us fully in your lecture. Thank you, ma'am. Thanks a lot for this. And we definitely want you to come at our university sometime.
Sure. Thank you. So, Sumanji, I may say one thing on my thanks slide also. Usually people don't talk on thanks slide. So as people can see here, Natraj. You can see.
I want to ask that because in the last lecture few years back, you showed me that Natraj mementos been installed at that. Yes.
I thought you started with the shloka from Gita, and I would end with the Natraj here. Let me tell you why I'm putting Natraj here. These on the left hand side, this is our CMS offices. You can see here, and just beside this is a big metal Natraj. This Natraj was brass Natraj. This was gifted by Government of India, Department of Atomic Energy to CERN. And they have very nicely, I have a very good photo which I'll include in my next lecture. They have installed the Natraj right here, just on the side of this, our CMS offices, with a very beautiful lights around it. At night, it looks beautiful. You can see the shadow of Natraj on because of the lights they have put there. So this is a gift from Indian government to CERN. So that's why I'm showing you this Natraj.
Really wonderful, ma'am. Yeah.
And secondly, if students are there, if they want any answer to any question which they can ask me later on, this is my email ID here given. So if I know the answer, I would reply. Otherwise, also I'll reply.
So I think students already, many students already left because of their lunch and their preceding practical timing as per the schedule.
Okay, then you can put. So I think I'll stop sharing my screen. Is it okay now?
Thank you, ma'am, once again.
Now I can. I was not able to see you because I was seeing my screen only. So let me stop sharing.
Thank you very much, ma'am, for sparing your valuable time and making the participants aware about the greatest event ever was designed and conducted by scientists.
Thank you very much. It was my
making
pleasure.
Us present here about how much time was required to accomplish the goal, how many scientists were involved all over the world, and how much collaboration is required globally for a particular event like that. I hope participants were benefited, including us, the WIS members. And yes, Suman has rightly said that you have given us a virtual tour, and I really enjoyed your slides. And really, it was a live phenomena again.
Thank you.
We observed there at that time also, and now it was again. Thank you very much, ma'am.
Yes, I in the beginning was going to say that those who have already attended this talk to excuse me, so that
no,
because atom
has made it so interesting.
Yes.
Being not the part of that particle physicist. Many are from the material and science and from the biology also. Being not the part of that, still we are been feeling indulged in the lecture fully.
Thank you so much. No, it's your
And truly, ma'am, you recognizing how the role of women in the science, apart from the various hurdles and the challenges, you were the first in that field, and you betterly give us that how we can put full of our effort for the benefit of the society, benefit of the science. Truly, ma'am.
Thank you so much. Yes, at that time, very less. Even when I was doing PhD, some in the machine lab, I was sitting on a microscope working. Some collaborator from US had come. So he came, he didn't look at me, just talked to my supervisor for half an hour. And when my supervisor introduced me that she is doing PhD, I still remember his expression. Oh, women doing PhD.
Yes.
So he said, I didn't, in our country, at that time, even in US, he said, usually women are up to secretary level and very few women are there at higher studies. So that's why I didn't talk to you. He didn't say hello to me even at that time. so I still, his name was Stiller. Said, I still remember his expression after my guide introduced me to him that she is doing PhD. So now the things have changed. Now things have changed.
But ma'am, for sure, you just put one brick and now it's a full pillar.
It's full, yes. So now the ratio of girls studying physics is reversed.
Yes.
Earlier, in 60 we were 4 or 5 girls. Now 4 or 5 boys and rest. So that is
for every field of basic sciences, truly.
Basic sciences, yes. Yeah. Slow change is there. Mindsets have to be changed, as your Vice Chancellor very rightly said that, and one has to believe in oneself and then keep on going.
Yes.
Okay, thank you so much. So you are finishing your words.
So for formal vote of thanks, I would like to invite Dr. Ruchi Gupta. Over to you, Dr. Ruchi. Ma'am, yes, you are audible, but voice is coming little low. Pitch is little low.
Hello?
Yes, ma'am, now it is fine.
Okay. So, our esteemed chief guest, Professor Suman Beri, Honorable Vice Chancellor, Professor Somnath Sachdevaji, Professor Neera Raghav, other respected faculty members, our most valued invited guests, participants, dear students, a very good noon to all. It's my privilege to have the opportunity to propose a vote of thanks on this occasion of felicitation program of Science Carnival 2022. Science Carnival 2022 was started on January 22. 4 activities: science quiz, poster making, science storytelling, and PowerPoint presentation were held in this Science Carnival. And we got an overwhelming response from students. 299 students participated, and this response was beyond our expectations. So thank you, students. Each activity was preceded by a lecture by eminent speakers. Today, on the occasion of International Day of Women and Girls in Science, we got opportunity to have our valedictory function, and also we had an excellent and knowledgeable lecture by Professor Suman Beri. So I, Dr. Ruchi Gupta, on behalf of all the members of Women in STEM Forum, Kurukshetra University, Kurukshetra, and on my own behalf, extend a very hearty vote of thanks our today's distinguished speaker, Professor Suman Beri, for her valuable and knowledgeable words. Thank you, ma'am. I also want to thank all of our distinguished speakers for gracing our events and sharing their knowledge with us. Thank you all distinguished speakers. A big thank to Professor Anurekha Sharma, and she is the backbone of this forum. It is because of her genuine efforts we could have this forum in this university. I also want to thank Professor Rohini Godbole ma'am and Dr. Ashutosh Sharma ji for their valuable suggestions that we get time to time, which helps us in shaping this forum. I also thank Professor K.C. Sharma, our ex-Vice Chancellor, to give his support for starting this forum in our university. I extend my thanks to first and second team of this forum also. Now I want to thank our present Vice Chancellor, Professor Somnath Sachdevaji, for giving us perfect logistics support and guidance, and of course administration grant due to which this event becomes possible. I also extend my thanks to RUSA coordinator for providing us the financial support to organizing such events. Now I want to thank Professor Neera Raghav for her guidance and efforts of day and night, without which this event doesn't make successful. Well, an event like this event cannot happen overnight. The wheels start rolling enough, so it requires planning and a bird eye for detail. We have fortunate enough to be backed by such team, very motivated and dedicated team members who knew their job and are result oriented. Thank you, Professor Neera Raghav, Dr. Suman Mehendia, Dr. Pooja, Dr. Suresh Dua, Dr. Sunita Dalal, Dr. Hardeep Sharma, and Dr. Anju. Thank you so much. Events are not possible without the enthusiasm of participants. So thank you all dear participants. At last but not least, I want to thank all of those who are directly or indirectly involved in organizing such activities for making this event successful. Thank you very much.
Thank you once again, ma'am.
Thank you, ma'am.
Thank you, ma'am.